All right, so this is the problem we are being asked to solve. It basically says you've got a design a lock. This lock, we're going to use full encoding. And as we use the full encoding, the lock controller has to unlock when *136 is entered, and then automatically locks afterwards. So it's going to be momentarily unlock and then lock again. So that's basically what we want. And they've been nice enough to give us the input in this form, where keys are 0, binary 0 is 0, binary 6 is 6, and then 7 is a star key.
Okay, yeah, got it. Mm-hmm.
So that's basically what it says. And so this saves us, because if you had to have 7 separate lines coming in, or 8 separate lines, 7 coming, that 7 input, it would be kind of ugly to do. So the first step, what is the first step in design? The first step in design is to do system diagram and state diagram, right? So that's what we're going to do. We're going to say, okay, here is my system. I've got 3 inputs coming in. I'm going to call this inputs x2, x1, and x0. And then I have basically one output coming. There is only one output, which is going to be lock. So you're basically, I'm going to call it, let's call it Z, just to stay with the theme of these problems. So Z, if it's 0, it's going to be unlock, let's say, or lock. Let's call that one lock. And 1 unlock. You can do it the other way. It's really not a big deal. But okay. And here we are saying if we got x2, x1, x0, we're seeing the representative keys 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So all the keys, this is going to be key 0, 1, 2, 3, 4, 5, 6, and 7. And that's pretty much it. So far, so good?
Yep.
Okay. So what are the states? Let's say we start in a reset state. That is a state which says, I don't know. I haven't got anything that makes sense to me, right? So I don't know any of the sequence. I have not got any of the sequence. Then you sit here unless you get a star, right? Because remember, it was
the first key.
Star 136, right? That's what it wants before it unlocks. So if I get star, I'm going to have a state. Why make up names? We're going to have a state called star. Okay? That basically says I got a star, right?
Right.
And then the only other interesting thing for me, okay, if you get another star, you go here, right? If you get any other key other than 1, right? You're going to go back to reset because it's messed up your sequence. Your lock will now open. So if I get a 1, then I'll go to, now I've got a star 1. If I get a 3, that is cool, okay? If I get a 3, now I can tell the world I've got star 1, 3, 6. And if I get a 6, I'm cool. The combination is great. Then I unlock, see? So now we got some stuff. So here, inside here, we have the state, right? Over here, we have X's, right? And underneath, we have the Z. So if you get a star, I'm gonna stay locked. If I get this, I'm still locked. If I get here, I'm still locked. The only place I unlock is back here when I got it. Does that make sense so far? We're not doing any digital logic stuff. We're only doing what in real world, how the lock works so it doesn't work.
Yeah.
And I got to put some notes in here because I would say note any combination not shown goes to any input combination not shown, goes to reset. Okay, so the only other thing I have to show is star goes here. If somebody presses a star after they've done one, right? If they are here and somebody presses a star, it goes here. And all of these will have a 0. How are we doing so far?
I'm following.
Okay, so now what we've done the step 1, which is we've done the system diagram, we've done the flip-flop thing. Now we got to go to step 2, and our job in step 2 is to figure out how many flip-flop do I need to solve this. And since we are doing full encoding, we have to have the number of flip-flops should be high enough to give us enough variable. So when we do 2 to the power of number of variables, the number of flip-flop, this would need to be bigger than the states, number of states, right?
Right.
And in our case, the number of states is 4, which means the number of flip-flops are?
The number of flip-flops for 4 would be 3.
2.
Oh, excuse me, 2. Yeah, 2 to the power
I'm
2.
sorry, this actually is larger or equal.
Yeah.
I just have to have a unique state variable for each one of the states.
Mm-hmm.
So in this particular case, the number of flip-flops that I decide on are two. So that was step 2. I forgot to write it. So step 3 is actually, it doesn't say you have to do it, but I think if you do it the way we're going to do it here, it makes your life a lot easier. So what we're going to do in step 3 is we're going to assign values to each state.
Right.
So we've decided we have 2 flip-flop, therefore we're going to have 2 flip-flop variables, y0 and y1, and these are the name of the states. So we have 0, 0, 0, 1, 1, 0, and 1, 1. We can call this one reset. We can call this one the state star. We can call this one star, I think it was 1, right?
Yeah, yeah.
We can call this one 1, 3. How are we doing so far? So we're turning real world names into zeros and ones. If you're going to use computer, you got to do this. Question so far? If not, we can move on to the next step. The next step is really redraw this thing. So we know the way this is designed. The way this is designed is we're going to have a state. So we're going to have a y1, y0 in here. We're going to have x2, x1, x0 here, and we're going to have the output on the branch. And now what we're going to do, we're going to take that state diagram and redraw it. So instead of reset, we're going to say, oh, this is state 0, 0. Instead of star, we're going to say that is state 0, 1, right? And then for the next one, it's going to be 0, star 1. Star 1 is going to be 1, 0. And then the next state is going to be 1, 1, which is the state of star 1, 3. Actually, I'm sorry, there is no 6 in here. Yeah, 1, 3. Because at this point, you've got star 1, 3, right?
Yeah.
All right. So now we know when we get a star from here, the input corresponding to star, remember we did this earlier. Star is?
Was the star is what, 0, 1?
1, 1, 1, right?
Oh, you're talking about the X inputs. Yeah, star is your 7.
Yeah, it gets a bit confusing with the state and the other one. So this is going to be 1, 1, 1. The lock is going to stay 0, right? And then here, if we get a star, we're going to stay in the same spot and 0. And then if we get a 1, we go here, which is 0, 0, 1. And if we get a 3, we go here, 3, 0, 1, 1. All of these have an output z of 0, right?
Right.
And by the way, when we get a 1, 1, when we get a star, we're going to go back here. If we get a star, we go back here. And then if we get anything other than, oh, actually, I'm not going to even draw this one. So let's not even draw it. We just put a note. Otherwise, it gets really messy in a hurry.
Yeah.
So we're not even going to draw this one. So what we're going to say, we're going to put the note under here so we don't, did we get everything? Yeah, we got everything. So we're going to put a note in here when the note basically is going to say any input combination not shown goes to state 0, 0. How are we doing so far?
Good.
Good.
Fine.
All right. So this gets a bit ugly, but it's not that bad. So we'll see.
So one quick question. You have all these stars going back to the star, like
right.
Is that really necessary to put there? I mean,
not really, because the way I selected the state was 0, 0, which means all the values will be 0 when I'm trying to write the equation. I can almost ignore it, right?
Mm-hmm.
Otherwise, I will end up with 32 cases.
Yeah, I mean, every possible combination.
And I don't really want to do 32 cases. There's only a handful of them I'm interested. The rest of them, the next state is going to be 0, 0. I don't even have to care.
Right. Okay.
So in a real situation, I have to basically do this. I got to say, all right, here I've got the present state is y1, y0, right?
Mm-hmm.
And the next, and then the other things I have to pay attention to is x1, I'm sorry, not x1, x2, x1, and x0. This is going to have 32 row. And if you want to write the 32 row, you might guess. But you really don't have to, because most of them are going to be 0, so they're not going to have any effect on your equation for y1 plus and y0 plus and z, right? There's only one case, one situation where z is 1. Nowhere else matters. We don't even have to put the z in here if you don't want to, because I'm sorry. The only this we kind of skipped. There is something here, because we're gonna get. Remember, we forgot the branch. This branch I have to draw. So this would be 1. So when you get a 6, that's the only time you get a 1.
Okay. Yeah, right.
Translate.
That's the only time it unlocks.
Yeah. So the z, we don't, there's only one case of z that is even interesting. So let's walk through 0, 0. So when I'm in a state 0, 0, the only input of interest to me is 1, 1, 1, which takes me to state 0, 1. Do you see how I'm doing this?
Yeah, but should we be putting the JK for the Y1, Y0 as well?
Hang on to that thoughts for a minute. Let's not make our life more complicated, because now we're going to go, instead of 2, I have to worry about 4 things, right? And we're going to do a shortcut in a minute. So hang on to that. So for now, we just want to do a present state, next state table. This is step present state, next state. This is our step 4, okay?
Okay.
So let's capture all of these, and we'll come back and deal. And then if I get a 0, 1, and if my input is 0, 0, 1, then I'm going to go to 1, 0. And the only other input I'm interested here is if I got a 0, 1, and I'm sorry, if I get a 0, 1, and I get a 1, 1, 1 star, I'll end up going back to myself. You see that?
Yes.
Yeah. So the next state is 1, 0, and if I'm in this state and I get a 3, I'll go to 1, 1 with a 0. But if I'm in this state and I get a 1, 1, 1, I'll go back to 0, 1.
Right.
Okay.
Anytime you have 1, 1, 1, you're going to go back to star unless you're already on the path.
Right, because you broke your sequence, so you have to start all over again.
Mhm.
That's almost like a reset thing. And then finally, when you're in state 1, 1, if you get a 1, 1, 0, you're going to go to state 0, 0, and your output will be a 1. We good?
Yep.
And then finally, if I get a 1, 1 and a 1, 1, 1 with star, then I have to go back to 1, 0 with a 0.
Yep.
So the rest, all other possibilities will give you 0, 0, 0. Because you're going to go to state 0, 0, and your output will be 0.
So just a question for like these tables. So, I mean, basically anytime x2, x1, and x0 are 1, 1, 1, it's going to go back to y1 plus 0, y0 plus 1. So could I have put xx for y1, y0, meaning like doesn't care what those are as long as x2
maybe you're getting ahead of me. I got to think about that.
Okay.
You might be right, but I'm not sure. So let's write. The next thing is you got to write the equation, and we'll find out. We'll find out shortly if that just could be done. So if I do a short, z is simply going to be the only time z is true is when it's y1, y0, x2, x1, and x0. Do you see that?
Z equal, yeah, anytime.
The only time is this.
It's only going to equal 1. Yep. Okay.
I don't really want to draw a K-map for a 5-variable thing to figure this out. So I'm going to use the simplified algebraic reduction in this case and see if I can come up with y0 plus. So y0 plus is here, right? Here, here, and here. The question is, can I simplify them a little bit? So I looked at these two. Look at these two. I better write them before I confuse you. So y1 not, y0, for every one, we're just writing the function, right? x2, x1, x0, or for this one, it's going to be y1 not, y0, and x2, x1, x0. Or the next one is going to be this one, right? This one. So it's going to be y1, y0 not, x2 not, x1, and x0. I have one more one to write. This was a long one. Okay, this one is going to be y1, y0 not, x2, x1, and x0. I think this gets simplified quite a bit if you go through and do the algebraic reduction on it. But I don't want to waste your time on my going through it right now. So if you look at it, for example, these two, you see that? y0 is not and that, so you can get rid of it. See that?
I can't see where your mouse is.
Okay,
I'm looking
so
at.
let me go ahead and put a red one on it. So these two, you see that?
Yeah.
These two gets reduced to y1. Actually, I'm going to write it over this. y1 not, x2, x1, x0.
Okay, yeah, I see. Because y0 doesn't really matter because it doesn't care what it is at that point. It could be a 1 or a 0, but that's same as long as y1 not. Yeah.
And then we're gonna do this. Then we're gonna see. Can I get rid of the? Yep, I can do this too. See that? Y1 is the only one that changes, right? So I have a y0 not x. Oh no. There's two things changing. Sorry, couldn't do that one. First one, we can do it with the last one, right?
Where are we at? Y.
So it's going to be y0 not x2, x1, x0. I'm going to let you do that, but even if you don't simplify it, I don't care, but you could simplify it, okay?
So if I looked at the table, I mean, you could kind of boil it down to whenever it's either, what is it? Let me see, 1. The only time it's not. Okay, so y1, y0 not. Yeah, okay. I mean, basically, it's always going to be 1 if x2, x1, and x0 are 1, 1, 1.
Yeah.
Or
And then you have to write the equation for y1 plus as well. And y1 plus, you have 1 here, you have 1 here, right? And you have 1 here. So it's going to be basically y1 not y0 x2, x2, x1 not x0, or you're going to do this one, which is y1, y0 not x2 not x1 and x0, and the final term is down here, which is all of them, y1, y0, x1, x2, x2, x1, and x0. So once you have this, the D flip-flop basically would be, boom, there is my, so, you have your x1, x2, and x3 coming in. I'm sorry, x0, x1, and x2 coming in, and you have 2 flip-flops, right?
Mm-hmm.
And if they're a D flip-flop, they're basically, for D, Y plus is equal to D. You're done. These equations are D equations. You're done, right?
Right.
For JK flip-flop, all you do is you run your Y0 plus, if this is J0, K0, and do this.
Oh, okay.
And here is your Y0 coming, and this is Y1 coming. And the rest of it is just a bunch of gates to put together, right? Nothing exciting. And by the way, if you want to do the same thing for T flip-flop, all you do is this.
Okay.
And your Z, basically, in this case, your Z is this thing. You just write the equation and the Z comes out. Doesn't matter which flip-flop you use, your Z is going to be the same. So let me stop the recording here and see where we end up.